well, welcome everyone to the start of today's session. I'm Jason Gumpert from MSDynamicsWorld.com. I'm pleased to be able to welcome Steve Endow to today's event. If you don't know him, Steve's a Microsoft MVP focused on Dynamics GP. And today's session is one that is based on a session that he's presented before that got really amazing reviews from people who sat through it. So I think you're really in for a treat today. We do want to keep today's event interactive. There's both a chat and a Q&A block you should see to the right of the main presentation area. Chat is great for just sort of non-question communications that you want to share with us, comments, feedback. If you have a question, I would recommend putting it into the Q&A block so that we can make sure that we get to all of that. It's just more structured, easier for us to follow and make sure we get to it. So that's the use of the tools today. And with that, I am happy to hand things off to Steve Endow. Steve, welcome.
Great. Thank you very much, Jason. And thank you to MS Dynamics World for hosting this webinar. And happy Friday, everyone. Beautiful Friday morning here in Los Angeles. Hope everyone is doing well. And I don't know if it's International Coffee Day or National Coffee Day, but whatever it is, I'll take any coffee day I can. So sit back and relax and enjoy. And my name is Steve Endow. I'm a Microsoft Dynamics GP MVP. And I was asked to prepare this presentation for the Dynamics GP Tech Conference in Fargo in August. And at the time, I wasn't quite sure how to do this. It was a little tricky to figure out how to prepare something on SQL query optimization. So it seemed to go over well, so I've done some refinements, and hopefully you find it enjoyable. Okay, so again, I'm Steve Endow. I'm the guy on the far right there, and this is a photo from that gathering in Fargo in August, and this is a group of many of the Dynamics GP MVPs that attended, so really rare collection of 9 MVPs in one spot, so that was a very fun event. And as Jason mentioned, I want this to be an interactive webinar, so speaking in front of a group at a conference is great because I can get the feedback. You can see me waving my arms and acting like a goofball, and I can see what the audience is feeling. You can ask interactive questions. So webinars can be kind of challenging, but I want to try to make this as interactive as possible. So if I ask a semi-rhetorical question or if I want feedback, feel free to use the chat feature. And if you have a specific question that you want an answer for, feel free and use the Q&A feature in WebEx. And we will have an additional Q&A session at the end. And also, this will be recorded, and it will be available on the MS Dynamics World website once it gets published. And also, I have posted the slides and the SQL scripts for download on the bit.ly link shown here, which is case sensitive. So if you do want to download that, you can during the session or at the end. And so everything is available. You don't need to scramble and take a lot of notes during the webinar. Just feel free and absorb it and ask questions. And if you have any audio technical difficulties or video or display technical difficulties, you can ask a question to the host, and Jason can help sort you out there. Okay, so with that, let's get started. If I can figure out how to get my slides to behave. There we go. So what is SQL query optimization? And this is kind of I think some consider it like a black art or something that's really esoteric and you'll never understand it.
Hey, so, Steve.
Yes.
I'm sorry to interrupt. So there are several people who are not seeing the slides now. I do see them. I'm wondering if it's sort of a partial issue with networking or something like that. But okay. Would you maybe like pause and unpause, or maybe stop sharing and start sharing again?
Okay. And I see some audio is cutting out. So there could be some individual network connection issues, but let me reshare. And okay, so I am resharing my monitor.
Yeah, and I do see it. I see your mouse moving.
Okay.
So I think we're good overall. There could be some individual issues. I'll try to help people with in the background.
Okay, and so this will be recorded, so I apologize if there are some audio or video glitches, but hopefully it works out for most people, and Okay, and so some people are reporting back that different browser may be behaving better than others. Chrome seems to be working fine for some. So, okay, so SQL query optimization, is it some magical black art that requires voodoo? And I used to think that as well, but after I studied for this session and found some simple examples, I think I can offer you a different way to think about it. And will hopefully offer you a very simple way of stepping through the process. And this is going to be on the simpler side. We're not going to get into super complex optimization, but hopefully you'll have enough to be competent to start the process. And honestly, after you learn some of these tools and techniques and terminology, I generally think you'll be in the top 10% of SQL users in terms of your ability to think about query optimization. So moving forward. So here's a question you can respond in the chat session. If a user asks, how long should this report take? What is your answer? If you've developed that report or if you work with queries, how do you respond to that? So if they say, this report's taking a long time, how long should it take? So an open-ended question, what do you say to them? So feel free to respond in the chat. Do you say, yeah, 5 minutes is perfectly fine? Should take 60 seconds. What is your standard for reports? So it depends. That's a good one. Depends on the data in the network, depending on the data and the hardware resource. So that's a common answer. It depends. It depends on the report, the complexity, how much data, all sorts of variables. So let me put it this way. If it depends, when should you think about optimizing a SQL query? You know, when the user says, well, this is taking a long time, when should you tell them, well, that's okay, that's perfectly normal? When should you say, well, okay, let's look into considering optimizing that or see if we can optimize in it? And so what's your criteria? It depends on the data. So I'm going to give you a different way to think about it. And it's completely arbitrary. It's not right or wrong, but it's one approach that I've taken to try and just have a standard so that I can say, well, this is acceptable or this might be time to take a look at it. So let's put some context around this discussion. So first of all, the context around this presentation is I'm assuming that we're working primarily with custom queries for your ERP or CRM system. The reason I mention custom is because oftentimes we cannot do a whole lot about the system provided or out-of-the-box query. So if an aging report in an ERP system takes 5 minutes, it can be extremely difficult to troubleshoot or optimize that particular query. But for custom reports, you generally control the query or can control how that report runs. So generally have a lot more latitude on custom queries. And also there are two categories that will differentiate. One is an interactive query, where a user is sitting there waiting for the query or report to finish. That's very different from a non-interactive query or a scheduled task. If that scheduled task runs at midnight and it takes 5 minutes or 50 minutes or 2 hours, it may not matter. So it doesn't really need optimization if no one is waiting around for it. As long as it doesn't time out, as long as it's running okay, you may not really care how long that query takes. But interactive queries are a special kind of animal. And when you get users complaining about how long queries or reports take, that's when you get the phone call and typically have to deal with that. And another differentiation is this is not application performance troubleshooting. So if an entire application is slow, that's a much more complex topic. That could be due to a lot of factors. So we're going to narrow this down to just queries. So SQL queries that you can control in an isolated manner, such as a report or a lookup or something like that. Okay, so signs you might need query optimization. And I think this is one of the big hurdles. Oh, 4 minutes isn't too bad for that report. But if the user's waiting 4 minutes, that can be pretty frustrating. Or, well, it's querying a lot of data. I saw that in some of the responses. It's a lot of data, so it may take a long time. And then if the report starts taking too long, well, it used to run fast. I don't know what happened. And then lastly, there's often some resistance. So if someone developed a query and the user comes to them and they say, well, this is taking too long, I often see a lot of pushback. Well, I don't think it needs to be optimized. And you'll see potentially some defensiveness among the people who have to create the reports. And there could be various reasons for that. But sometimes you want to be kind of gentle when you're addressing the query optimization discussion. So let's just get past that. And let me tell you, it's perfectly okay for a query that used to run fast to run slow. Not a problem. It's just a query. It's no big deal. And there are many reasons for query performance to change over time. As data in a database grows, queries often need to change or be adapted. When you first start out with a new application or a new system, you may have a 500 megabyte database. Queries run blazing fast with zero optimization. But when you move to a 50 gigabyte database, those exact same queries can crawl and behave completely differently. Also, as reports change, parameters change. So if you modify a report that used to work fine, once you change that report or add a few parameters, it can completely change how that query runs, how SQL optimizes it, the indexes that are used, which we'll touch on. So all of those changes can affect query and report performance. And changing a single column in a query can make a huge difference. And so you may think, oh, the user wants to add this field to a report. No big deal. Let me add that to the query, add it to the report. My report is taking forever now. Also, adding a single row to the result set can make a huge difference. This one really surprised me, so I'll show you an example of that. So just accept that queries occasionally need to be optimized. It's not a big deal. And then once you optimize them, a couple months later, they may need to be re-optimized yet again. So it's an ongoing process. It's perfectly normal. There should be no defensiveness or fear about doing that. It's totally normal. And hopefully I'll give you some tools today that can help you make that happen. So where do you start with this? So I asked early on, what is your criteria for what is taking too long? And I came up with a completely arbitrary rule, and I call it my 3-second rule. And I once had to deal with some queries that took forever, and I optimized them more. And I got them down to under 3 seconds. So from 30 minutes and not completing, all the way down to 3 seconds. And that was on a 1 terabyte database table. It was really intimidating, but as I learned how to optimize queries, I realized, the queries either complete quickly or they don't. There's some middle ground like 2 seconds, 5 seconds, 10 seconds, but I said, well, let me come up with a 3-second rule. If it's taking 60 seconds, I can generally get it down to 3 seconds. Obviously, there are exceptions, very complex queries, loads of data, but for most of the queries that I do for users, you can get it down to 3 seconds. Next, there's always a better way. You may not know what that way is, but when you have a query that's taking 60 seconds, generally there are tools, techniques, and ways to restructure your query or optimize it that can improve performance. It will generally not be obvious, and it's going to take some time and research to figure that out. But piece by piece, you can generally optimize it and find a better way. Last is question SQL dogma. I was taught things years ago or told things anecdotally. You should not use temp tables. Those are bad. Cursors are bad. XYZ is good. And I took those as the rules of thumb. Well, oftentimes those weren't necessarily accurate, or those may have been applicable to a particular situation. But over time, with improvements in hardware, improvements in SQL Server, changes to the way that SQL Server optimizes queries, those dogma assertions are no longer accurate. They may be accurate only in some situations, and in your situation, they may not be applicable. So question those rules when people tell you do this or do that. So there are also some considerations here. So cost versus benefit. If a query is taking 60 seconds, but it's going to take 6 hours to optimize, is it worth it? Maybe not. So the 3-second rule you need to put in context. If it's taking 5 minutes and it's going to take 30 minutes to optimize, sure, it's probably a good investment. Next, simple versus complex queries. A simple query is obviously going to be much easier to analyze, diagnose, and optimize. I just worked with a complex query. It was very scary. It was a nightmare. Multiple temp tables, multiple nested stored procedures. It took hours just to try to figure out how to optimize one query within that 500 query spaghetti code. So simple versus complex queries is a totally different game plan that you'll need to have. Lastly, solutions may vary dramatically by query and environment. So when I show you these test queries on a test table with fake data, they're going to look really simple and easy. But in your complex real-world environment, you may have to take a completely different approach. So that's why when you see discussions of query optimization, people say, well, that's great, But in this environment, that won't work. And so that's very true. You have to consider that.
Hey, Steve, we have a question.
Okay, a question. Go ahead.
Should I review the GPHATV for optimization of, or just use the MS one?
So funny that's mentioned. That was one of them that I just recently looked at. And so that refers to the Dynamics GP Payables Management Historical Age Trial Balance Report. It's a fairly complex report that lets you produce a financial aging as of a particular point in time. So we can go back to December 31st, 2016 and show you what things looked like. That was what I just worked on and what I described. Extremely nasty stored procedure with multiple nested stored procedures, multiple temp tables, hundreds of statements, dozens of cursors. And that one, I would say you're kind of in a losing battle. I think it's right for optimization. I'd love to work on it, but that's an example of an extremely difficult one where you'll quickly run into some roadblocks and start scratching your head. But it is possible. For those complex out-of-the-box delivered queries, I'd say you're probably better off using the out-of-the-box unless, like Victoria Uden and I team up and rewrite that, and she can offer it on her website, for instance. I see a question about the bit.ly URL again, and that's bit.ly/SQL optimization with capital SQL and capital O as part of that, case sensitive. And I'll go back to that at the end in the Q&A, and we'll see if it works. The bit.ly is a little finicky, so. Okay, any other questions? Okay.
I'm not seeing any others.
Okay, we're going to jump into the demo portion. This is going to be a fast-paced demo. Lots of things are going to be covered. Indexes, sargable query, statistics, execution plan, lots of stuff going on. So let me jump over to this query. Okay, so this is based on a blog post on a website called techrecipes.com, and I have this in the sample script, which is part of the download, and I have it listed on the slide here. And this author came up with what I think is a fantastic introduction to query optimization using the concept of sargable queries. There are many other concepts to query optimization, but he just picked this one, which is kind of a beginner topic. And I think what's particularly good about his technique is he used what I would call a differential query optimization approach. So he has some scripts on his website to create this sample table. So I created a sample database called employees. And he has scripts to create a table called employee test. And the scripts will create 100,000 records, and this is what they look like. So we have an ID column, which is just a numeric identity column. We have a random number going into salary, random date going into date of birth, and we have a bunch of random data going into employee name. And this is kind of helpful because it can show you a more realistic way that indexes can behave. If you have the same value in all these fields, indexes will behave very differently. So the random data is pretty important. Okay, so we have 100,000 columns, and this is what the data looks like. And this is also helpful for demonstration purposes because if I work with a given product like Dynamics GP, which is what I normally work with, it's very difficult actually to come up with example query optimizations. I tried for hours, couldn't come up with some good ones that showed the behavior that I wanted, but the author of this blog post has come up with some great examples that demonstrate some simple techniques that can help you learn the process. So in addition to creating this table and populating it with test data, he adds 3 sample indexes, and I'll briefly talk about what indexes are. So he adds what's called a non-clustered index on the salary column, meaning we are going to index this column called salary, and we'll be able to query that in an optimal fashion. He also adds an index, a non-clustered index for date of birth, and he also adds a non-clustered index for employee name. And so indexes are SQL Server's way of trying to look up data quicker for particular columns. And let's jump back to the slides to talk a little bit about indexes. So the analogy and what the word index was likely based on is the index in the back of the book. So if I want to find something in a book, I want to find Adam Charles, a French sculptor. I look at A's and I can find based on that name. So This happens to be indexing the contents of a book, or in this case over here, we have an index of names, like say you have employees or a club. I want to look for Kayla Andrick. I can jump to the A's, find that employee name. But this index, and the index in the back of the book, is indexing based on last name. Well, what if I want to find someone based on the first name? Can I find Kayla? Well, unfortunately not. This index appears to be last name only. And when you look in the index over here, I see Augustus. So if I want to find, let's see, Charles, all the Charles in the book, I may have a hard time because this is based on last name. So what's nice about SQL Server or database indexes in general is you can have an index on multiple fields. So I can look up based on employee name, or I can do a quick index lookup based on date of birth. So it essentially slices and dices the data and provides us with a quick way to look up based on each of these columns. You can even do what's called a composite index. Maybe I want to index based on date of birth and employee name, or employee first name, employee last name. You can do them many different ways, and so there's a lot of flexibility here. Now, what does non-clustered mean? That's a technical term in SQL Server that says, this is an index based on the data in the table, but I'm not going to sort the data in the table physically. I'm just going to create a separate index, just like an index in the back of the book, that lets me look up this data. The data in the actual pile of data or in the table may be sorted a completely different way, like maybe how it was inserted physically. But my index is not going to affect that. I'm just going to have an offline index that lets me look up names quickly. So that's what the term clustered or non-clustered means. And in SQL Server, you can only have one clustered index per table because you can only sort the data one way in a table. So if you have a table, it can only be physically sorted one way. It can't be sorted by salary and also physically sorted by date of birth and by employee name. So typically you have what's called a primary key, and let me just expand this here. You see my table. I will go to my indexes, and you'll see that there is a primary key here, and it is clustered. It's very common with primary keys. Not all systems do that, though. So in the case of Dynamics GP, we have primary keys that are not clustered. So it depends on the system, depends on the database design. But in this example, we have a primary key based on the ID column, and it is clustered. So there's a physical sorting of the data based on ID. And I'm glossing over some technical points there, but that's an easy way to think about it. So the author of this exercise says, okay, let's create some non-clustered indexes so we can do lookups on salary, date of birth, employee name. Great. So let's see what that looks like. I'm going to do a query of selecting the employee name from this table, and I want to know all the employees where their name, the left first character, is A. Really simple query, right? So let me run that. Great. So I get results. I get 3,000 rows, and you see all of these employee names begin with A. Perfect. Well, my query down here I see ran in 0 seconds. That's awesome. This must be a great query. I'm super happy. Now I'm going, just to give a little more details on this, I'm going to choose an option called Set Statistics Time On. Because this shows 0 seconds, it's really hard to see. Even though there's 100,000 records in this table, this query runs really fast, returns results really fast, and I can't really tell how long it takes. So now my employee name query still ran in 0 seconds, 3,000 rows. Let's look at this Messages tab. So when you use Set Statistics, you'll get some messages about what happened. So I see that the elapsed time was 263 milliseconds. I'm pumping my fist. I'm really proud of that query because it's perfect, right? Anyone have any thoughts on whether this query is good or bad? So when you run it on a 100,000 record table, you're thinking, this is awesome. I can roll this out to production. But there's a catch. So there's a question here. Are indexes created once per table or every time you run the query on the table? So the indexes are created essentially, I think of them permanently. So once I run these index statements, the indexes are physically created, they physically exist and are attached on that table. And when you run a query, the query looks to these indexes, or the query optimizer more specifically says, do I have an index that I can use to look up that data faster rather than having to read the entire table. So it's essentially a permanent object in the database. Now those indexes can't get old or stale. So if you add a bunch of data, those indexes can become fragmented and need to be re-optimized and updated. So there's a lot of technical details, but you can think of them as permanent objects that the database can use going forward. They are not rebuilt every single query. So I ran my set statistics time on, and I see 263 milliseconds, which is trivial, right? Less than 1 second, split second, blink of an eye. I'm really happy. But let's do a little experiment. Let's do something called, let's enable a function called set statistics IO on. And that lets me see kind of what's going on behind the scenes and how much work SQL Server is having to do. So I'm just going to run it on my original query, left employee name 1 equals A. I want all employees that start with A. I'm going to execute. Again, 0 seconds, lightning fast. I'm super happy. And you don't have to know what any of this stuff means. Consider it, technical gobbledygook, but just look at the numbers. We're going to focus in on this one number, logical read 683. That sounds pretty good. 3,000 rows of a 100,000 row table, 683. I'm stoked. Well, let's try a different technique. Instead of saying left employee name 1, which is what's called a non-sargable clause, let's try employee name like A. They're functionally equivalent. They're going to give me the same results. So let me just turn this off so I don't give away the clue. Let me run this query. 0 seconds, 3,000 rows. What's the problem? Everything looks great. So now this is the brilliance of this tech exercise, is a differential analysis of the two queries. You're going to run them at the same time, and we're going to see what happens. Both queries run, 3,000 here, 3,000 there, 0 seconds. Let's look at this. Logical reads 683. We thought that was great, but the second query, 24 logical reads. You don't have to know what a logical read is to know that 24 is probably better than 683. Huh. Well, what's going on there? Let's turn statistics time on and see if there's any difference in performance. And I haven't actually done this yet either, so let's see what my results are. So let's do statistics IO on, statistics time on. Again, 0 seconds. Okay, so 683 reads in 115 milliseconds because it got optimized. 291, 24 reads, 291 milliseconds. Well, that's interesting. Kind of surprised by that. Didn't expect that. Let's rerun it again and see if our times improve. Okay, so I can't quite tell which one is this. I'm surprised. I would think the faster one with fewer reads, but I'll have to look into that. But I think for now, we want to look at 683 versus 24. And why is that? And so as you see from this comment, the first one is what's called a non-sargable query. And that is a super geeky SQL Server term that means non-search argumentable query. That means when we perform this type of search, SQL Server is unable to utilize an index. Well, why is that? It's because we're using a function on the fly to look at every record. So every record it looks at, it has to say, well, I don't know what the left first character is, so let me perform this function on record number 1, see what the result is. Is that an A? Nope. Okay, let me move to record 2. That means it has to perform the left function on every single record. Very painful. Now if we go down here, we can say, well, SQL Server, take a look at the employee name. Let me know if it's like A, if it starts with A. And in that case, it says, great. What do you know? I have this index based on employee name that already lets me look up based on the first letter. Just like what we saw here. If I can get back to my, just what we saw here, we already have an index. So it doesn't have to scan the table. It can say, great, let me look at my index, find the first letter. If it's A, let me return the results. So this is a non-sargable query. This is a sargable query. And this usually comes into play in the where clause. Also comes into play in the joins, but for now we'll focus on the where clause. So let me just focus on set statistics IO and look at the IO activity or output activity or what it needs to do to perform that. And we see a pretty big difference, 683 to 24. Okay. Oops. Okay, so let's move down. Similar example, we have year, date of birth. So for every record, SQL Server has to read the date of birth, on the fly extract the year, see if it's 1952. Alternately, we can do a sargable query, exactly the same results. Date of birth is greater than or equal. Go ahead. Oh, was there a question there? Okay, sorry. Date of birth is greater than or equal 1952 or less than 1953. So let's run this. Okay, so you see we have 1,200 results in 0 seconds for both queries, and you notice 231 logical reads versus 5 because it's able to use that index. And I'll show you a graphical example of what that looks like as well. Okay, so any questions about sargable queries versus non-sargable queries?
So there's one inquiry wondering why there's one time measurement of 0 CPU time.
Yeah, and so when you get down to these really quick queries, it becomes very hard to analyze them. And so that's why doing a query optimization demo is very difficult. So if I were to add 500,000 or 1 million records to this table, we might put some load on the SQL Server, but oftentimes SQL Server is so fast that it doesn't even register on the I/O. And so let me see if we can get back to, was it the time that showed CPU time? Yeah, I think it was. So yeah, CPU time 63 seconds. So let's see what happens if we add this back on to. And the reason I'm turning it off every time is sometimes you can accidentally leave that on, and that adds a little bit of load to your server. So one caveat that I should probably mention is you'll probably want to do this on a non-production server. Do this on a test server, test database. You probably don't want to bang away on your production box doing this optimization. So you can see here 286 milliseconds versus 134. It's behaving a little bit better now, 47 milliseconds versus 16. So when you expand this out to a complex query, these can be dramatic differences, like half the time. Let's see, Ashley, I assume there's a list somewhere. Oh, I see. List of sargable versus non-sargable functions. Yes, if you Google SQL sargable operations or non-sargable, there are many discussions on this. It is somewhat obscure, surprisingly. So only kind of in the SQL Server optimization space and the SQL Server geeks tend to get into the sargable discussions, but there are several articles that discuss what a sargable query versus a non-sargable query. And I'll give you a simple rule of thumb. If you have a function or something occurring on the left side of your equal sign of your where clause, that's probably not good. You want to push these functions to the right side. So, and then also, if you have a function in your where clause, that's generally not a good sign as well, because that means every record it's having to evaluate what's going on with that record. It has to do that function, get a result set, figure out if it matches, whether it's on the left or the right. So in general, functions in your where clause, not a great idea, and they'll probably push you into the non-sargable territory. So you'll see like, between, and we'll show us a few more examples here. So for example, here we have the year. It's on the left side. Causes problems, makes it non-sargable, whereas we can do an evaluation here greater than or equal or less than, and also the between function works. Yes, and a great way of stating it, sargable predicates take advantage of the index. That's kind of the technical lingo, so that when you use a sargable where clause here, it means SQL Server can utilize an index. That's basically sargable means index utilizable. Okay, so now let's move on to the next step. So here we were using a where clause. We were selecting one column, and we were using where clause that filtered on that one column. So in our result set, we only got one column back. What happens if we want two columns? We want to select date of birth and employee name, and we want to filter on date of birth. Our indexes are only on one column. So what happens? Let me Sorry, my mouse is bouncing around. So let's add employee name to the query. And now we see date of birth, employee name, 0 seconds. We're golden, right? 1,200 rows, 627 in each result set. Well, 861 reads, 861 reads. What happened? We have a non-sargable query here, and we have a sargable query here. So our sargable query should obviously be faster. What happened? Well, remember in my presentation when I said adding one column can completely change how your query behaves? We just demonstrated that. So when we only have date of birth, SQL Server can use indexes because, like I showed in this example, you can go to this index and look up one value. Well, what happens when we ask for a second value? Well, SQL's like, I only have a date of birth index. I can look up date of birth, but I can't find employee name in the date of birth index. So that means I need to look through every single record in the table, whether you're using a sargable where clause or a non-sargable where clause. I still got to do the whole table. So we lose the benefits of our query here. So on the fly, let me just see what happens, and I'll jump ahead, and we're going to create a new index. We're going to create a non-clustered index, and we're going to demonstrate a couple of things. We're going to show how to create an index. So there are several ways to get to this window, but if you expand your tables, your indexes, I'm going to say new index, and as I mentioned, you can only have one clustered index per table, so we have to choose a non-clustered index. And there are a few other examples that we're not going to get into, but let's choose a non-clustered index. And what do we want to index off of? Well, our where clause is date of birth, so let's index off of date of birth and say OK. Now, SQL Server, I think it was like in 2007, SQL Server 2007, they introduced this fantastic feature that I embarrassingly didn't know about until this year, called included columns. So rather than having to index off of multiple columns simultaneously, or have a composite index, which is costly and complex, let's just add an included column, and I'll explain what that means. So we're asking for date of birth and employee name. We're indexing on date of birth, so let's add employee name as an included column. And that means when SQL Server looks up on the index of particular date of birth, it finds 1952 and it says, oh, I see included columns are employee name. Let me grab that as well. So when I find an index value based on date of birth, I can also query at the exact same time the employee name looking at the index only. I do not have to look at the actual physical table. So if I say OK, I'm going to rerun this query. I just added this. Here, let me rename that. Let's see if it lets me rename it. I hate these default query names. Come on, rename. So I'm going to call this non-clustered index, and you can call it whatever you want, but employee test, and I'll call it DOB employee name, just so that it's a little more recognizable. So that's a non-unique, non-clustered index. Now let me rerun my queries here. What's going to happen? Obviously 0 seconds, 1254 for both rows for both result sets. Look at that. 780 logical reads with my non-sargable index, 9 reads with my sargable index, sargable query. So huge difference. And that was because we created an index that lets us look up date of birth to satisfy our where clause, but also adds our employee name as an included column to that index. This is amazing. So I'm embarrassed to admit I did not know about included columns because I don't typically mess around with indexes or play with them too much. But I found this while doing this presentation back in August, and my mind was blown. I instantly saw the benefits. So rather than having this big, heavy index that has a bunch of columns that SQL Server has to sort by and track and manage the order of, you can throw in an included column, which just tacks on this data on the side. It doesn't have the overhead of sorting based on that value. So we can sort by one value or just 2 or 3, keep this index light, but have included columns to speed up our query. And this introduces another term that is very important in query optimization, and is that of what's called a covering index. So when I perform a query with multiple fields, If I can find an index that includes all of those fields, that means that SQL Server can work with one index, it can satisfy my where clause, and satisfy my select statement and return all of the data in one shot based on that index only. It doesn't have to look to the table to get more data. So before you saw when we were querying date of birth only, our index for date of birth was a covering index. It satisfied our where clause, it satisfied our select statement. So it looked to that index only, didn't have to touch our table, it was a covering index. But you saw when we added employee name, we no longer had a covering index. SQL Server had to look through the entire table to figure out, okay, I found date of birth, that's great. Now I got to look up the employee name. I got to go back to the table. But once we added that new index with DOB and employee name, we now have a new covering index. So covering indexes for me are generally the holy grail. Now, if you have 57 columns in your select statement, highly unlikely you can have a covering index. And that's because all of those fields in an index make it very heavy, very costly, which we'll get into some of the pros and cons of indexes. They're not all positive. So you can't index every single column with every single select statement possible because that requires overhead. Okay, so some good questions here. How would you go about having an included column where the data is a function? Included column year DOB. Interesting question. I haven't thought about that. I would say that is probably not ideal. So can you include a function in a column? It's not a standard index, that's for sure. Is it possible? Maybe. I'd have to look that up. Is it optimal? Probably not ideal. But that's a good question. There are probably some other ways to do that, like an index view, but as I may mention later, index views are very costly, very limited. So whenever you start to do things like have functions as part of your indexes or search criteria, you start to incur some cost. So you may need to look at different approaches to doing that. And the second question is, what happens when index gets stale? Does it return old data? Great question. So indexes over time can become stale, and there are a few terms around that. One is the index statistics, or your table statistics, or database statistics. Indexes have to use estimations of what the data looks like in order to optimize themselves. And over time, those database statistics can get old, so the distribution of data can change, and those indexes may start to perform poorly. So there's a term called update statistics that you can run on a database, and you'll hear that term mentioned. And also, your indexes can become fragmented, meaning you built the index in January, 100,000 records were inserted, and the table now looks like a jumbled mess to the index. Those indexes are no longer optimized, so you can rebuild those indexes. So there are several maintenance processes you need to perform occasionally on indexes, depending on the volume of data that gets inserted or deleted, or if data radically changes. So if, in this case, unlikely dates of birth employee names don't typically change, but let's say you have transaction data where the underlying data is radically changing. So maybe delivery dates are changing from January to February. That may affect your indexes. So you need to re-index or update your indexes in order to achieve your best performance by the SQL Query Optimizer. So the SQL Query Optimizer, this engine, whenever you run a query, it's running behind the scenes saying, I'm going to take a certain amount of time to try to figure out which index I should use. I'm going to look at this table, look at the data distribution, say, well, should I use my date of birth index or should I use the DOB employee name index? Which one looks the most appropriate for the data I have in the table? And if your indexes are old or if your statistics are old, it may make the wrong guess. And so you may get poor performance even though you're indexed properly. So hope that answers that question. So here we see a really radical improvement. Covering index provides us with 780 versus 9. Massive improvement. Okay, so now what happens if we query date of birth, query employee name? We have a non-sargable query here. And with our sargable query, where we added the covering index, let's see what happens if we add a clause. So we won't put that burden on our non-sargable query. but we'll add a burden here where we want to filter on both DOB and employee name. Let's see what happens. Okay, 644 results. Even though we added employee name to our where clause, even though technically employee name is not an indexed column and it is only an included column, look at that. It was able to utilize that covering index and maintain its performance even though employee name is only an included column. So for me, the included column indexes are fantastic. And I'm going to start playing with those and using them whenever possible. Let me grab a little coffee here.
Steve, while you do, there's a question, is there a danger of having too many indexes?
Yes, excellent question. As I mentioned, indexes have pros and cons. So every time you insert a record into the table, what needs to happen? So if I were to go back to my book example, if I were to add new names to my book or my directory or add a new chapter in my book, what do I need to do? I need to index that new data. So I have to look at it, figure out what's in there, add new entries into my index. Exact same thing happens in SQL Server. So if I go back to my table and I add 100,000 new employees, every record that gets inserted, SQL Server says, okay, what's the salary, what's the employee name, what's the date of birth? Where do I insert this record into my indexes? So in addition to the physical insert to the table, SQL Server behind the scenes, without you even knowing it, is having to update every single index that exists on that table. It's costly. Now, you may not even notice it. It will happen so fast, thankfully, that you don't really notice it. But if you have 5, 10, 20 indexes on that table, and if those indexes have 5, 6, 7 different key columns on it, or a dozen included columns, you are going to have some overhead there. Additionally, in addition to the CPU or I/O or processing overhead, imagine all of that data. So this index is actually storing the representation of date of birth. It's also storing a representation or a pointer to the employee name. So there is storage overhead. So your indexes, there are some queries where you can analyze the data or the storage space consumed by SQL Server databases, tables, and indexes. You may find that an index is actually larger than your underlying table. So you may have a 500 megabyte table with a 600 megabyte index store for that table. So indexes can be very costly for I/O and storage. And you may not realize it because unless you go looking for the index overhead and storage constraints or storage overhead, you won't even realize it. So you do not want to start slapping on indexes left and right. And for those of you familiar with Dynamics GP, you may know it is indexed to the hilt. There are just dozens and dozens of indexes. Tables have 5, 6, 7 indexes for seemingly really strange combinations that I'm not sure are optimized. And so you need to be careful when considering indexes, especially with a delivered product like Dynamics GP, CRM, nav, etc. You don't want to just start adding indexes left and right. You want to think carefully about them. Maybe you can optimize an out-of-the-box index. But the problem is, what if an update drops and recreates that index? There go your customizations. So you may want to say, well, let's add our own custom index for this particular report that takes way too long. We run it 4 times a day. It's going to save us 30 minutes a day to index it. Probably a good use case for adding an index. But you'll want to be considerate and monitor performance. So there are downsides for adding indexes. Hopefully that answered the question. Okay, so in this case, we added a covering index, dramatic results improvement, and it even handles additional where clauses. So great result set. So yes, we did that. Okay, so now what happens if we change to SelectStar? So rather than just selecting the 2 fields, what if we need all fields in a table? What do you think is going to happen if I do SelectStar? We saw before when we went from 1 field, just date of birth, to 2 fields in our select statement, we lost the ability to utilize our index and we had to have a new covering index. What if I do SelectStar? Anyone predict what's going to happen here? Well, if we have to select all fields, obviously none of our indexes are going to be covering index at that point. So let's see what happens. Well, there we go. We're back to the same. It can't use an index because it says, well, I can only look at one field at a time based on your indexes, or maybe two based on that new index we created. So I'm stuck at the same. So whether it's a sargable or non-sargable, it's having to scan, that's a technical term, a table scan every single record. It's having to look at 100,000 records in that table in order to fulfill either query. So this is some dogma that you'll hear, never do SelectStar. And I thought, okay, that sounds kind of reasonable, but in what I do, I often need every column in a table. Literally, I need to pull every column in a table for an integration to return the result so I can process the data. So in this case, I cannot utilize the query. So this is a great demonstration of why SelectStar is painful. So in a report, if you only need 5 columns, only query those 5. Do not query 30. And this is exactly why. It basically eliminates your ability to use indexes on most cases. Now, if you only have 3 columns in a table, maybe there is a covering index you can use. But on most real-world tables, you have quite a few columns, and you can't utilize indexes with a SelectStar. So this really taught me, okay, I get it. Now I see why I shouldn't do SelectStar. It's not about the number of columns. It's not even about the amount of data it returns. You know, if you need that data, you need that data. It's that by doing SelectStar, you're almost guaranteed you're going to lose your covering index if there is one. So whenever possible, try to avoid SelectStar. So that's a great lesson there. Okay, so let's see what happens if I do a calculation. Now this is interesting. It's not just that you can't do a calculation or you can't do a function. It depends on whether that calculation or function is on the left side of your where clause or on the right side of your where clause. So I'm going to do a query, and the salary data is random, so we'll see what result sets we get. So I'm going to do a query where I'm performing a calculation on the left, or I'm performing a calculation on the right. And exact same results. Here I'm dividing salary by 2. Here I'm multiplying a value that I want by 2. Let's see what happens. Okay, there were no rows in this case because, well, let me see if I can find a good salary example. These are on the fly because this data is generated randomly, as you saw. Okay, so let me take this one. Sorry, this is a little on-the-fly demo. Divide by 2, and yeah, of course it comes up with that. Let's see if this even works. Of course, I had to get a 0.5. I should have known that. Okay, so let's do this. Or times 2, this. Okay, now I did apostrophes around this. Let's see what happens. I don't know if that was part of my demo. Okay, let's see what happens here. Oh, sorry, on the fly demo prep. You're all screaming at me, you did it wrong. Okay, so I'm doing something wrong here. No, that should have been right. It's divided by 2. Let's see if a number works. Okay. Okay, so not sure why, but I think we'll get the same result. So here, regardless of the result sets, 177 logical reads versus 2 logical reads. Obviously, this is non-sargable. My operation is on the left side. Here, this is sargable. It's able to use the salary index intact with no funny business to say, okay, let me look up salaries that have this result set. Even though it's a calculation, it's able to pre-calculate this number, get the result, and then do a lookup in the salary table. So that's another example. You can do calculations, just be careful whether it's on the left side or right side. Yeah, so integer math in the first query, I think so. It did work before on my other demo, but depends on what number I'm choosing. But really the demonstration is sargable versus non-sargable, so the number of result sets doesn't seem to matter. Okay.
Steve, there's a couple more questions that came in on the included columns.
Okay, let's see. Can included columns covering indexes be used inside GP or other Dynamics apps? Yes. So in Dynamics GP, if you need to optimize a custom query or even an out-of-the-box query where you find an index can work better, you can include included columns. And I'd recommend trying to use that. I think included column indexes are fantastic. So if possible, you index. So here's kind of my rule of thumb, and I'm still kind of figuring this out. When you have a where clause, I want to index based on these fields. So I'll want to have an index on date of birth and employee name. And if I have additional columns in my select, I'll want to add those as included columns. Does that make sense? So your included column, or excuse me, your index will target these fields in your where clause. The included columns will be any additional fields you're looking to query, because SQL Server needs to sort and filter and select based on this, but it only needs to return data for these guys. Okay? So hopefully that helped. So fair to say that multiple indexes do not affect each other in query performance, only in overhead. Good question. So multiple indexes can affect query performance. In these examples, these are very simple. We're only hitting one index at a time. But imagine a complex query where multiple tables are being queried, and any given table may be queried in multiple ways, or maybe there are different joins. SQL Server may simultaneously utilize multiple indexes for a table. So even though you add one, adding one index may affect the overall query execution plan. So you need to be careful. You may add one index that improves performance in one area, but it actually degrades performance because it changes how the query optimizer sees the data, and it may not use another index that's more appropriate. So if you start adding indexes, and while troubleshooting that GP historical age trial balance query, I found that I started changing fields on an index, it radically changed the execution plan. So it improved it in one area, it caused problems in another area. So you need to look at the entire query execution plan, which I'll show shortly, to show you what that looks like. So you can't necessarily add an index and think you're improving things. You need to be careful that it doesn't break something as well. Okay, more coffee. Okay, so if, let's see, we covered SelectStar, we covered non-sargable with a math operation here, and these are very similar, changing to greater than, same results. So you can do a greater than, or you can do a between. So you can just change your where clause in order to make it sargable. You go from, that's interesting, 177, 175. So we didn't get a big boost here. And I suspect that's because this number is so large. Let's see what happens if we decrease it. 177, 175. Fascinating. So you can see, depending on your data, depending on your result set, depending on your table structure, you may have reduced. See that? So just changing the size of the amount of data it's having to scan in the index can dramatically reduce the value of that index. It's not the index fault, it's just that you're asking to look at a lot more data. So here, we see that because we're looking at a very large number, it's basically having to look at most of the index. So that index has minimal benefit. But if we reduce the potential result sets, excuse me, let's go to here, we can have much better query results in theory because we're telling SQL Server to focus on a very small section of that index rather than a very large. So that's an interesting side effect. So again, you need to start playing with these, but that's what's great about this. You can see that this approach or technique, this differential analysis, you can run the same query in a couple different permutations. You can say, what happens if I do this? 177, great improvement, 175. Okay, so when I open up the query, the where clause, I get very little benefit versus a non-sargable query. So maybe you just restructure and take the hit. Okay, so let me just see how we're doing on topics and time. It is 10 o'clock, so we are running long, actually. So let me So we talked about indexes, sargable queries, statistics, I/O, and time. Let's talk about execution plans really quick, and let me show you what that looks like, because that's where things really start to get cool. So execution plan is a graphical representation, at least in this tool. You can have a text version, but I'm going to click this little button up here that says Include Execution Plan. And in addition to getting my I/O results here, I'm going to get a pretty picture. So you see that in this case, we didn't get much benefit because we're doing SelectStar. Let's actually move that up and do our covering index here. So 780 logical reads, 9 logical reads. What does our execution plan look like? Here we have an index scan because it has to scan the entire thing, and it happens to be using our covering index. Here we have an index seek. So rather than having to read the entire index to find every record where the year is 1952, it can do a seek, which is like jumping right to 1952 in the index, grabbing the index that we want, and performing a sort. So this seek is generally better than a scan. And this is a great number here. When you're doing your actual execution plan, the query cost relative to the batch, both queries, this query took 97% of the cost. This query took 3. You don't need to be a rocket science in SQL to know that 3 is going to be much better than 97, just like 9 is going to be better than 780. So this is a great way to compare 2 queries and see that, we have a winner here. Index seek better than index scan. So let's take a look at one more. So when we did a SelectStar, what happened? Here we had to do a clustered index scan, and that's on our primary key because that's a clustered index physically sorted. It gave up on our indexes. It says there's no index that's going to fill it, so let me just scan the entire table. And we have a slight improvement on the non-sargable query, but only because we have an order by. So we can go down the list and see what our execution plans look like. And we see we were able to do an index seek here, reduces the cost slightly in this example of the 3. Let's just do 2 here. Okay. So for those of you that need to take off, I apologize, I'm running long, but we're going to continue if that's okay with you, Jason.
Yeah, absolutely.
Okay, so I'm going to run long, but for those of you that need to take off, the recording will be published on MS Dynamics World, and there will be a link included in the presentation. Any good book you can recommend to get more knowledge on the topic. I think once you start doing this, you start to drill into the topic. So you can Google index seek versus index scan. Now that you have some of the tools, you can just query SQL query optimization, and you can see a lot of topics. And I have some URLs in the slide deck of other resources you can check, websites that focus on this topic. So with that, I'm going to plow on, and let's see what else we need to cover. Execution plans are really great because they're visual representations. And let's see if I can get an order by. Okay. Well, I don't have, let me try. So execution plan, scan versus seek, we talked about that. Index scan, it can jump right to the index where it wants, versus a seek, a table scan or a table seek, it has to scan the entire thing. Whereas a seek, it can jump right to the point where you're searching for based on your where clause. So that's a good argument for having a where clause that limits your result set. The smaller result set, the easier it can seek in that index and find exactly what you're looking for. Versus a scan, it has to look through everything. And we talked about included column indexes. I think they're awesome. Use them when possible to add columns to your index to get a covering index. Okay, so we covered indexes. So what are some lessons from that? In your where clause, limit the result set whenever possible. A smaller result set will generally give you better results for several reasons. Sargable queries, we talked about that. It can do a search argument that hits an index. If you don't have a sargable query, it generally has to do a scan. Index scan, generally more costly than index seek. Now, you may see these terms in your queries, a key lookup versus an RID lookup, or key lookup and an RID lookup. Even though you're indexed, it may need to go back to your table and do a lookup for additional data. I found these are very costly. So if possible, try to add a covering index that will handle these. It's tricky though. I found out it's often hard to get rid of these lookups for complex queries. So if you look up some discussions on key lookup and RID lookup, you'll generally find that these are expensive. And at the bottom of the slides, I have some links: sargable query demonstration, statistics IO in identifying index scan problems. So these footnotes down here can help you drill into some of these discussions. Now, store procedures versus views. Store procedures are generally said to be pre-compiled. So they're pre-built. SQL can optimize them using indexes and statistics to understand how they should be run without incurring the cost of this query optimizer to plan it. Whereas views are often on the fly. So also store procedures often have parameters. Again, that helps you limit the result set when you can have parameters that go in your where clause to filter your store procedures. So I used to use views a lot. I now prefer store procedures whenever possible because you can pass in parameters to limit the result set. Now, some applications, like if you're familiar with Dynamics GP Smart List or Smart List Builder, oftentimes you can only use views for certain applications. But if possible, try to use a store procedure. Index views. I got a question at the GP Tech Conference. What about index views? Wouldn't they be good? My answer is no. If you look at the requirements for index views and the limitations, I think they are a solution looking for a problem. They are highly limited in what they can do. They have severe performance implications. Here's an article from Brent Ozar on index views, pros and cons. I would just stay away from them. I just can't imagine the bizarre scenario where those may be useful. I'm sure there are several, but I'd rather have a good store procedure or properly optimized query rather than an indexed view. So we talked about clustered versus non-clustered. Clustered is a physical sort order. You can only have one per table. Composite index is multiple columns that are indexed versus included columns where you tack on additional fields those index so the data is returned with your index seeks, hopefully. A covering index is the holy grail that includes all of the columns of your query, both the where clause and your select statement, minimizing the fields that you want to minimize the fields that are selected with your covering index so you can utilize them versus doing a SelectStar. And we briefly touched on index overhead. Adding indexes adds I/O and storage overhead, and adding indexes can affect your query execution plan and confuse the SQL Query Optimizer, so you want to be careful when adding those indexes. Okay, so yes, there's a question about GP Smart Lists and why they're so slow running queries. And I think that's more the GP Smart List engine. It's just a very unoptimized application, and it's trying to pull the data and display the results. Whereas if you run the query, SQL Server Management Studio, Crystal Reports, SQL reports tend to be much more efficient with how they pull and display data. So yeah, that's GP specific, and I agree, it is slow. So Management Studio options, we saw the option Set Statistics I/O. That's one way to have a metric of how your queries are performing. Do you have a lot of I/O operations? And also Statistics Time shows you execution time in milliseconds as well as CPU time, so you can get a gauge of how your queries are doing. And what's great is when you compare two, as you saw, you can see side by side which one is better. Next up, we briefly touched on actual execution plan, which is a fantastic, very, very deep topic that I recommend looking into. We didn't have much time to cover that, but once you get in more complex queries, you see the query execution plan just explode with this flow chart of data, and you start to look at each operation to see where you can optimize. But be careful. There's an estimated execution plan and an actual execution plan. Estimated will get you close, but there will be some key differences, estimated versus actual, and I recommend, if possible, using actual execution plan, because that shows you the real deal, not what it thinks it might use. And there can be some minor differences between the two that are crucial for optimization. one caveat, complex queries may take a very long time to display the actual execution plan. While testing the payables, historical age trial balance, and GP, for one portion, one query out of that entire process, it took an hour for SQL to retrieve the actual execution plan, even though that query only took 3 seconds. It took an hour, and SQL Server, essentially, the Management Studio crashed because the execution plan was so big. So be careful with it. Only do this in a test environment. Include client statistics, I'll note, is available. That's an option in Management Studio to display what the client sees. It's not what happens on the server, but what the end client, like the reporting tool or Management Studio, sees, how long it took to get all the data downloaded, how many records were returned, things like that. I find it a little less useful, but you may find some scenarios where that's beneficial, where the query runs great on the server, but it takes forever on the client for some reason. You could troubleshoot that way. Let's see. And there's a few footnotes here on statistics, I/O, and execution plan, and client statistics, and when you might use those. So here's an example of what a very complex query might look like, that execution plan. It's huge, it's daunting, it's intimidating. And so what I recommend is go to the bottom right. Go to these very last operations. These tend to be the ones that are costly, and these tend to be the ones that you'll troubleshoot. So this looks like an index scan. This is an index seek. How can you get rid of these scans? Now, this is displayed because this is an example of how one column in a query can change your execution plan. This is before, massive. He added one column to the query. It changed to this. Now, whether the performance of this versus this is better is a completely different question. But when SQL Server is doing this many operations, it's going to be moderately complex. And if you can get it down to this, it might be a huge improvement. So this is a crazy example, and this is a great article demonstrating how one column, if you add that one column to your report, it may go from simple to nasty. So you've got to be careful whenever you change your queries. So managing indexes in SQL Server Management Studio, we showed that. So in Table Designer, you can manage your indexes and keys, create new indexes, create included column indexes. You can also use Object Explorer and look at table properties, which is not quite as useful. So if you go to Object Explorer, you can double click here. And strangely, it gives you, well, in this case it didn't. But if you, depending on how you're looking at it, you can get a different view that has fewer columns. But I generally recommend drilling into the table, going to indexes here, versus, let's see if I can get to it, going to design. This is how I used to do it, and I realize there's a lot that's not showing here. You go into design, click on the manage indexes and keys. This is a different way of looking at it. I used to use this, but there are things you don't see. It's not as obvious that you have included columns. Okay, so you need to start looking around to see, well, do I have included columns? I can't really tell. So I find now that I go into here, go into properties, and you get the complete, come on. Oh, I think because I had this open. I can get the complete index properties window, and you can see included columns and better idea what's going on. Okay, so those are the two options. I recommend Table Designer, excuse me, Object Explorer. Order by. Is order by bad? I just learned this. I used to think that you always want to have an order by, because when you have a query that's going to go to a report, users always want data ordered. You generally don't want reports or query result sets that are completely random based on the results from SQL Server. However, I've recently learned that you generally do not want to include order by in your SQL Server queries. My jaw dropped. Again, this is one of those dogma things. I heard always order by. Now I learn it's bad. And the reason is that when you try to do an order by operation, that order by is very costly in SQL. So here I'm going to order by salary. Let's see if I can demonstrate this. So even though I have a sargable query, oh, this is SelectStar. Sorry, let's see if I can get a sargable query. So you notice here I have a sort operation. When you see this operation, you notice it is costly. 65% of this operation was the sort. whereas 35 was only retrieving the data. And the danger is that if you have a lot of data, this sort can require SQL Server to do either an in-memory sort or a temp table sort where it has to write to disk. So if you have a lot of queries in a result set, then this can have to hit disk and it has to build kind of on-the-fly indexes. So let's see if I can limit this or change this and see what happens. Let's see if I can cause a spill. Probably can't. So I have fewer records, the sort is less costly, but if you have a lot of data, it causes what's called a spill, a sort spill. And going back over here, in your query execution plan, you may see a little yellow triangle here that's called a sort warning. And this will say, hey, you might want to know about this. I'm having to spill over to tempdb because I can't store all those records in memory, having to write to tempdb, resort the data, reread tempdb, and then provide the result sets. So here's a great article from Redgate website, Never Ignore a Sort Warning in SQL Server, and you'll see a mention in there, if at all possible, avoid order by. And I recently discussed this with some SQL Server folks. They confirmed. If you can do sorting in your reporting tool or the end tool on the client, fantastic. If you can avoid that order by clause in your SQL, you can avoid that costly sort operation in your query. Now it's a matter, do you want this sort to be performed on the server or on the client? You can test it and see which one behaves better. But if you're getting a sort warning here with a little yellow triangle and you're spilling to tempdb, you probably want to remove that sort or simplify it somehow. Okay. And here's an example of what can happen with sorts, and it also demonstrates what can happen when you just add one additional row. Again, this is a crazy example by the Brent Ozar team. They did an example query, top 100. They then did top 101. Well, there's a hard-coded element in the SQL Server query optimization that when you query 100 records, you'll get a certain behavior from the query optimizer. But above that, it behaves differently and assumes it needs more memory. Top 100 took 51 seconds. Adding one record to the result set tripled the time, 160 seconds. That's crazy. The reason was they had an order by clause here, and when they ordered by, SQL Server had to do a sort. You notice the cost there, 97% of this query was sorting it. Here, it was able to do it in memory, and that's what those little yellow arrows mean. Here, you get a sort warning. That's the yellow triangle with the exclamation point. That means that it had to spill to disk. It had to use the tempdb on physical disk to push that data there because it's saying, well, I'm over 100. This might be a really big result set. I better prepare for it. It sucks up a big chunk of memory behind the scenes to prepare for that, and it spills to disk regardless just to be conservative, and then it will perform the query. So that's why it takes 3 times longer for one additional record. Mind-blowing here. And the lesson that he also talks about in these 2 blog posts about this is he initially did an estimated execution query plan. Both were identical. It showed the same thing right here, 50%, showing a sort with the little yellow arrows. Everything looked great. So he said, well, why is this taking so long? Then he did an actual execution plan, and he said, aha, this is why. That one extra row changes the sort operation, and it's only visible in the actual execution plan, and it kills the query. Crazy, crazy stuff. So this is a great article. His team comes up with some really great examples. So, okay. So what are the lessons here? Let's talk about joins as well. Joins are a complex topic. So we just did simple select statements on one table. When you add in joins, things get much more complex. You're dealing with multiple tables, different table indexes. The way you write your join statements matters. You want to try to join on indexes. So in general, limit the number of rows to be joined, minimize the columns included in a query, just like our other queries, review the execution plans and indexes, and see if you're hitting indexed columns in your where clause and your join statements. Your join order may affect performance. So in general, you'll hear that SQL dogma. People say, oh, if you join this table first, it shouldn't matter. first versus second, but it may. SQL Server Query Optimizer looks at the join order, tries to guess what's better. You may find in examples where you have a very small table and a very large table, the join order matters. SQL Server will guess wrong. So you may want to start your join with the smaller table. So join smaller table to larger table. That way, SQL Server looks at the smaller table first, has a smaller result set to join to the bigger table, versus the other way, it has to scan the entire large table to figure out how to do the join. So join order does matter with big differences in size of the tables. And if you're doing many joins, Query Optimizer may not be able to look at 12 joins and figure out how to do it. At a certain point, it says, look, I've spent enough time, I give up. This is the best I could find in that time period. Go with it. If you resort your joins, you may get better results. So here's some great articles on tuning joins, optimizing joins, and physical join operators. So some homework there. Okay, so these are some great resources. Google is obviously your friend for specific topics, but Redgate has some great SQL performance blog posts, and they also, I think they have a newsletter where you can get email notifications. Brent Ozar, his firm and his team, they do SQL training, really crazy SQL optimization and troubleshooting that they blog about with their customers. So I'd sign up for their blog and their newsletters. He has a daily newsletter, and you're just amazed at what they find. Some of those examples, like I showed, additional column and additional row. SQLperformance.com you might see in result sets, and SQL-server-performance.com. And SQL Server Central tends to come up in my Google results. So these are all things, if you see these names, you should be able to recognize them quickly when you're Googling around. And click on them. They tend to have some better results than other sites. Okay. So with that, sorry for taking so much time. We're at 10:20 Pacific. So yes, you can download the slides. Let me jump all the way back up here and try bit.ly/SQL optimization case sensitive. And let me just see if I can find a browser here to see if that works. I tried it 3 different times last night, and that points to my OneDrive. So it's a little tricky to do a link to OneDrive. So bit.ly/SQL optimization, and that is case sensitive. So you have to have the SQLO capitalized because I messed up on my first try. So in that case, that takes me to my OneDrive with an MS Dynamics World folder, and it should automatically download a zip file for you, or you click on OneDrive and it should download. If you have problems with that, then feel free and ping me. Zoom, on, come on, come on. This is so, you've got to be kidding me. There we go. On Twitter, @Steve Endow, and what I'll do is I will tweet out after the session where the slides are, try to give some links. If you can't get them that way, you can email me on my Gmail address, and I also, I guess I can blog about it and post it on my MS Dynamics GP Land blog at blogspot.com. So with that, let me see if there are any questions. Even if we use big table, left join, small table, it would be better to use a small table, right table, assuming that. So you may think that most of your data is coming from the big table, but if you're joining against a smaller table, you can't get more result sets generally in a join than what's in that small table. So if your result sets are limited by the number of records in the smaller table, start with the smaller table. Make that on the left side of your join. So you're joining 100,000 records to 1,000,000 records, not 1,000,000 records to 100,000. You can experiment both ways, see if it makes a difference in your query. But as a general rule, try to start with the smaller table, even if that's not what you're trying to query primarily. So let's say you have a small customer table but a giant orders table. Even though you want orders, try starting your join with the customers, joining to your orders table, and see if that improves your results. It may not work in certain situations. Let's see. How and why would you use no-lock? So no-lock, if you're familiar with GP, you will see no-lock a lot in the GP queries. And there is debate about this, contentious religious debate on whether no-lock is bad or good. The SQL gurus on the database side will say you should never, developers will say you should never use no-lock because you might get dirty data, and no one wants bad data in your result set. So no-lock means, hey, run my query, but SQL Server, I don't want to interfere with anyone else. So run my query without locking the tables. So people may insert or update data in the 30 seconds when my query is running, and the results that I get back may have slightly old data. Now, the developer may say, that's bad. You should always have current great data. You don't want to run financial statements with an old journal entry or old debit or credit. While true, you may also see that when someone runs a big report, it's not good for them to lock the entire table for 5 minutes while that report is running. So there's pros and cons. In general, GP errs on the side of caution of locking and will add no locks. And so you may get some slightly old data in your smart list or in your GP reports or in other queries or inquiries. That's the risk they chose to take. Now, how many records can be updated in the time your query runs? Well, if it's 3 seconds, probably not a lot. So there's pros and cons of that. Some people say never use no-lock. Other people say use it. In the GP world, given how GP works, I tend to go with no-locks on a production environment, especially with the long-running queries, because if you lock that GL 10,000 table, you can cause some serious data entry problems. Okay. So another mention, the recording will be published on the MS Dynamics World website. That'll be listed there, and they typically tweet out when that recording is available. Okay. So any other questions here? Thank you for the presentation. You're welcome. I hope you enjoyed it and thought it was great. Hi, Jack. I know one of the attendees. I'm glad it's going well as a GP admin in your new gig. So feel free. I'm pretty active on Twitter. This is kind of my non-public personal email that I only use for things like this. So that's the best way to reach me because my main email is overflowing, and I write blogs on Dynamics GP Land. And it looks like we're wrapping up. So unless there are any other questions, Jason, I think we can wrap it up at about 90 minutes. And sorry it went long, but glad we had the time to do that. And look for the recording and the slides.
Thank you, Steve. Yeah, no problem on going a little long here. We will be communicating with all of you. If you have any other feedback, look for the little survey that pops up after the event ends. We'll definitely make sure Steve sees that as well. Well, Steve, great job. Thank you so much for taking the time to prepare this and to present it. Much appreciated.
Thank you very much for hosting, and everyone have a great Friday and a fantastic weekend.
All right, and with that, we will conclude today's event. Have a great day, everybody.